Welcome back to class. In today's lesson, we're going to be talking about Pythagoras' theorem and trigonometrical ratios. Our objectives are to describe Pythagoras' theorem, to describe the primary trigonometrical ratios, to find one ratio given another ratio, and to describe relationships between the ratios. First up is Pythagoras' theorem. Now, what exactly is it? It is an idea that has been around for a really long time, as far back as the ancient Egyptians who built the pyramids. Essentially, what we do here is that we're taking three squares and playing around with them to use them to form a right-angled triangle. In doing that, you realize that once you get a right-angled triangle to form, that the square on this side plus the square on that side is equal to the size of the square on this side. That is, the length of this side of the triangle squared plus the length of this side squared is equal to the square of this side. Essentially, that gives us Pythagoras' theorem. Pythagoras' theorem works only with right-angled triangles and is used to calculate unknown lengths. In this triangle here, we have a situation where this side is 3 units, whatever the length of the unit is. This side is 4 units, and this side is 5 units. So, if we should write it down, this side, 3 square plus 4 square would be equal to the longest side, which is 5 square. There's a reason this side is the longest side. It is the longest side because in this triangle, this angle here is the largest angle. The right angle is the largest angle, and so the side across from that angle or opposite to that angle is actually the longest side. In any triangle, whichever side is longest is usually opposite to the angle with the biggest value. So here we are. This side is 3, this side is 4, and this side is 5. So 3 square, which is 9, plus 16, which is 4 square, is equal to 25. And as you add these, 9 plus 16, you'll realize that 25 is 25. So using letters A, B, and C, we can say then that if this side is B, that side is A, then A square plus B square is equal to C square, or whatever lettering convention you want to use. But this is essentially the idea of Pythagoras' theorem. We use it to calculate unknown lengths, as was said earlier. There are some things that are called Pythagorean triples, and this triangle here, we call it the 3, 4, 5 triangle, because one side is 3, one side is 4, one side is 5. Is a very, very special one, and it tends to come up on a lot of questions in your CSEC exam, often at the multiple choice. If not this one, then a multiple of this one. They call them Pythagorean triples. So, for example, if we should multiply this triple, 3 numbers, by a number 2, for example, then we would get 2 times 3 is 6, 2 4 is 8, 2 5 is 10, and so on. And if you should multiply it by 3, then 3 3 is 9, 3 4 is 12, and 3 5 is 15. All of these numbers work with the setup that we have here. So 9 square plus 12 square would give you 15 square, and 6 square plus 8 square would give you 10 square. It's just a nice little thing to know. Sometimes if you know these things going into an exam and you see the question, then you don't have to stress about working it out. So how exactly does Pythagoras' theorem work in terms of calculating sides? We can calculate pretty much any side. Using the two sides that form the L, and here's our L, those are what we tend to call the shorter sides. The sides that form the L means that the sum of the square of those two sides, so in this case we're going to do it 3 square plus 4 square is equal to 5 square, remembering that the idea behind Pythagoras' theorem says these two sides square, A square plus B square is C square. And so in our case here, we're going to have x, because x here is the hypotenuse. This is the 3, 4, 5 triangle, but we're going to work it out just the same to show. So 9 plus 16 gives us 25. And adding those, 25 is equal to x squared. And now we need to find our square root. So the square root of x squared gives us the square root of 25. So x here gives us 5. In this example here, using the 6, 8, 10, so we already knew that this was 8. But just to show, then these two sides make the L. So you could write it down as x squared plus 6 squared gives you 10 squared, which means x squared plus 36 is equal to 100. You do the subtraction. 100 minus 36 would give us 64. And so x would be equal to the square root of 64, which is 8. And pretty much this is how we use Pythagoras' theorem to find the length of one side given two other sides. When we mark an angle apart from the right angle, so this is our right angle triangle, this is our right angle, it is marked, so we can know that which angle is the right angle and which side is the longest side. When we mark an angle that is not the right angle, as in this case, we marked this angle, we call it theta, it's a Greek letter, then we can give the other sides of the triangle names. The longest side of the triangle has a special name. We call it a hypotenuse. Sometimes we just refer to it as the H for hypotenuse. The side that is in front of the angle, here's the angle. So the side that is in front of the angle or directly opposite to it, we call it the opposite, sometimes O. And the side that lies next to the angle is the adjacent side. Sometimes we call it A. Now, the side BC is also lying next to it. These two sides are lying next to the angle, but this one already got a name. We call it the hypotenuse because it is the longest side, special name. The other two sides are given names based on where this angle is. So because this angle is here, theta, this side, which is right across from it, is called the opposite side, and that is what it means in mathematics when we say opposite. We say directly across from. So the opposite side is AC. The adjacent side is AB, and the hypotenuse is BC. Let's look at another example where the angle is in a different place. Now, the angle is up here. This is your right angle, which means that here is your hypotenuse. So the hypotenuse is DF. This side is directly across from the angle, right in front of it. Because of that, it's called the opposite. So EF is the opposite. And the other side is the adjacent side. This is actually very important that you learn how to name the sides based on their position. Naming the sides leads to choosing the right tools for the job that you have to do. So the angle position determines which side is opposite because the angle is here, straight across, that's the opposite. And we know that once we have a right angle marked, the side straight from it is called the hypotenuse, and the other side is called the adjacent side. Now, when we compare two sides at a time in relation to an angle that is marked, we get what we call trigonometrical ratios. There are 6 ratios. Let me point that out early. But for CSEC purposes, for CSEC purposes especially, only 3 of them are concentrated on. So there are 6, but we only concentrate on 3 at the CSEC level. So when we combine two sides at a time, so we compare them, a ratio is essentially a comparison. So when we compare two sides at a time, and in relation to the angle that is marked, we get these 3 ratios. So we call this one sine. So we say the sine of the angle. Let me write it further out. Sine, this is how we write it in short, and this is how you would see it on a calculator. So we say the sine of the angle this is the angle, is equal to the opposite side. This is the opposite side divided by the hypotenuse, and this side is the hypotenuse. So sine is the opposite side divided by the hypotenuse. We say the cosine, we shorten it as cos. It's cosine, C-O-S-I-N-E. The cosine of the angle is always there, is equal to the adjacent side. So we take this side and this side together, A over H. And the last one we call the tangent. And the tangent of the angle is equal to the O over A, as in O divided by A. So you take two sides at a time with the angle. The first two, take the opposite and the hypotenuse, and we call that sine. Take the adjacent and the hypotenuse, and you call that cosine. Take the opposite and the adjacent, and we call that tangent. And these are the three primary ratios. Actually, these are more primary than this one because there's a relationship between these two that actually gives this one. But generally, we tend to refer to these three as the primary ones or the main ones. All right. Now you notice out here that you have three other things. So the sine of the angle is opposite over the hypotenuse, or the opposite divided by the hypotenuse. The angle itself is to find an angle, we use what we call the inverse function. So this is a function, it takes in a value, it gives out an answer. This is the inverse of that, and the inverse takes in a number and gives out an angle. The cosine will take in an angle, gives out a number. The inverse cosine function takes in a number, gives out an angle. Same thing for tangent. You put an angle at tangent of an angle, it gives you a number. The angle here would be equal to the tan inverse. And as I'm seeing it here, this should actually be tan inverse and not cos. So tan inverse would be opposite over adjacent. All right, moving on. Now, just as important as it is to learn to name the sides correctly, it is also important to learn how to write down the ratios correctly. So here we are going to write down for each triangle the sine of the angle, the cosine of the angle, and the tangent of the angle. Before we do that, we need to name the sides. So the angle is here, which means that this side straight across from it is the opposite. This is the right angle. So the side right across from that is the longest side. It is the hypotenuse. And the other side is the adjacent. Because we write sine of angle is equal to opposite divided by hypotenuse, and cosine of angle is equal to adjacent divided by hypotenuse, and the last one, tangent of angle, is equal to opposite over adjacent. Some persons long ago, not sure who they were, coined this phrase called SOHCAHTOA. Some students find it easy to use to remember the three ratios. So SOHCAHTOA, meaning sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in this triangle here, we can write down the sine of the angle, the cosine of the angle, and the tangent of the angle. The sine of the angle is theta, is equal to the opposite over the hypotenuse, which tells us that the sine of the angle here is equal to 3 over 5. The cosine of the angle is equal to the adjacent side divided by the hypotenuse. And in this situation, the cosine of the angle, the adjacent side is 4, and the hypotenuse is 5. And the tangent of the angle is equal to the opposite side divided by the adjacent side, which gives us that the tan of the angle is equal to, the opposite side is 3, and the adjacent side is 4. In this triangle, here's our angle here, which means that this side over here is the opposite. This is our right angle, which means this one over here is the hypotenuse. Sometimes your questions will say that your triangle is not drawn to scale. Sometimes they'll draw them really weird, and you have to use the fact that the right angle is opposite to the hypotenuse to see them, because they won't always look at the lengths that they're supposed to be. And because this is opposite and hypotenuse, this one up here is adjacent. So we can write them down as sine of the angle, of this angle, is equal to opposite over hypotenuse, which is, opposite is 15 over 17. The cosine of the angle is equal to the adjacent side divided by hypotenuse, so it's 8 over 17. And the tangent of the angle is equal to the opposite side divided by the adjacent side, which is 15 over 8. Finally, let's look at this one. Again, the angle is here, so we want to know which side is opposite. The side right across from it is opposite, so this one is opposite. It is important, again, like I said, to label them correctly. Otherwise, once you start labeling them wrong, you are going to run into errors, because naming the sides incorrectly will lead to you choosing the wrong ratio to work the question. So this is the opposite. Here's our right angle, which means that this is hypotenuse. And here is the other side that we call the adjacent side. So again, SOHCAHTOA, sine is opposite over hypotenuse. So the sine of the angle, you must always say the sine of the angle, whatever the angle is equal to opposite, which is 2 over 2.5. The cosine of the angle is adjacent over hypotenuse, which is 1.5 over 2.5. And the tangent of the angle is equal to the opposite side divided by the adjacent side, which is 2 over 2.5. The place where you're most likely going to be asked to write down a ratio, it is most likely on the paper 1, on the multiple choice paper, when they give you a question and ask you to state the sine or cosine of an angle. On paper 2, you'll most likely be using it rather than just stating what it is. There are some special relationships between the ratios, and we're going to explore them a little bit here. And some of them that you should know. It's not required that you must know them, but it's nice to know them. And the relationships are quite unique, some of them even cute. Sine of 30. And when we say 30, we mean 30 degrees and 60 degrees. So let's write these down. The sine of 30, remember, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the sine of 30, here's our 30. This is our 30. It means that in relation to this 30, 1 is the opposite side. All right. So 1 is opposite. And in relation to this 30, this side is adjacent. And this side over here, opposite from the right angle, is the hypotenuse. Let's use that to write it down for the 30-degree angle. So the sine of 30 would be opposite over hypotenuse, which gives us 1 over 2. The cosine of this angle here is the adjacent side divided by the hypotenuse, which is root 3 or square root of 3 divided by 2. And the tangent of this angle is the opposite side divided by the adjacent side, which is 1 over the square root of 3. Let's look at the 60-degree angle now. For the 60-degree angle, this side is right across from it, so this side is the opposite to this angle. This one is still the hypotenuse, So the hypotenuse doesn't change, but the opposite will change depending on which angle you're talking about, and adjacent will change depending on which angle you're talking about. Hypotenuse never changes. So this angle, so this side now becomes the opposite to it, and therefore this side becomes the adjacent side to it. So for 60 degrees, the sine of 60 is opposite over hypotenuse, which is root 3 divided by 2. And the cosine of this 60-degree angle is the adjacent side over the hypotenuse, which is 1 over 2. And the tangent is the opposite side divided by the adjacent side, which is root 3. So you can see that there's a little relationship thing going on here between two of the numbers. You can see that the sine of 30 is equal to the cosine of 60 degrees. Both of them are equal to a half. You should also see that the cosine of 30 is equal to the sine of 60, and both of those are equal to the square root of 3 over 2. The tangent of 30 and the tangent of 60 are reciprocal to each other, but I'm primarily interested in these two. What do we notice about 60 and 30? Well, 60 degrees plus 30 degrees is equal to 90 degrees. And these angles, when two angles add to give 90 degrees, we call them complementary angles. So if two angles are complementary, that is, if A, whatever angle that is, plus B degrees is equal to 90 degrees, then sine of A is equal to cosine of B. Or you can turn it around, cosine of A is equal to sine of B. This is a very important relationship to remember. In any triangle, as long as the two angles add to give you 90 degrees, that is, they are complementary, then the sine of A will always be equal to the cosine of B, or vice versa. Let's look at another one. Here we have a isosceles triangle. So let this side be 1 and this side be 1. Then we need to find the length of this missing side. To find the length of this missing side, we can use Pythagoras' theorem. Let's do that first. Remember, Pythagoras' theorem states that the two shortest sides, when you square them and add them, you get the length of the longest side. Let's call this side x for now. So 1 square, let's write down Pythagoras' theorem first. It would say something like a square plus b square is equal to c square. So in this scenario, 1 square plus 1 square gives you x square, where x is our hypotenuse. 1 square is 1, but 1 square is 1, so 1 plus 1 is 2, is equal to the square root of x square, is equal to x square rather. And finding the square root, x is therefore equal to the square root of 2. So we can write that here, that x is equal to square root of 2. So this side has a length of root 2, or square root 2. For our purposes, I'm not going to find that number in a calculator because I want to keep it exact. And once you put this number in a calculator, it's an irrational number. You will not be able to contain it. So let's keep it as root 2. Now, what is the sine? Remember, sine is opposite over hypotenuse. So we have sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, which gives you your SOHCAHTOA idea that helps you remember the ratios. So for the sine of 45, sine is opposite. Take this 45 here. This is opposite. This side would be adjacent, and this one is hypotenuse. Sine is opposite over hypotenuse. So 1 over square root 2. Cosine of the angle is 1, it's adjacent, over hypotenuse, which is the same thing as 1 over square root 2. And the tangent of 45 is opposite over adjacent, which is 1 over 1, which is 1. So these three are also very important to remember. So in any triangle, any isosceles triangle with a 45 like that, then cosine of A is equal to sine of B if, let's state that very clearly, if A equal B. And here both sine 45 and cos 45 have the same answer. So cos 45 is equal to sine 45, which is equal to 1 over the square root of 2. And very importantly, tangent of 45 is equal to 1. These little things make a big difference when you're working out multiple choice questions. So tan 45 is equal to 1. Very important. All right. We are now going to look at how to find two other ratios given one ratio. Now remember, we said that there are 6 ratios, but for CXE purposes, we concentrate on only 3: sine, cosine, and tangent. And here, we say if the sine of the angle is equal to 11 over 10, then we can find the other two ratios related to that one. So in order to do this, the first thing we do is that we draw a triangle. So let's draw a triangle here. And let's put in an angle. Now, the sine of this angle is equal to 10 over 11. Sine, as you remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the sine of the angle is opposite over hypotenuse, which means this is the opposite side, this is the hypotenuse, this is the adjacent side. It's 10 over 11. So this side is 10, this side is 11. And what we want to find is the adjacent side. Now, by Pythagoras' theorem, this side square, let's call it x square plus this side square, 10 square, is supposed to give us 11 square. We know that the 10 must go here because the 10 is opposite, and the 11 is the hypotenuse, so we put it there. So x square plus 100 is equal to 121, which means that x squared is equal to 21, and x is therefore equal to the square root of 21. Again, we're going to keep that as is, and without finding the decimal answer. Now that we have this, we can write down the other two ratios. So phi, sine of this angle, is this. So the cosine of that angle is going to be equal to the adjacent side over the hypotenuse, which is square root of 21 over 11. And the tangent of that angle is going to be equal to the opposite side divided by the adjacent side, which is 10 over the square root of 21. So if a CXE question gives you one ratio, say sine phi is equal to 11 over 10, what is the value of cos phi or tan phi, then you can actually find the number. Now this angle here, we have another one. Let's practice it again. The tangent of the angle here is equal to 2. Let's draw a triangle. That's how we start them. Tangent is equal to opposite over adjacent. Opposite over adjacent, put in an angle. Then this is the opposite side, which means that this has to be 2 and this has to be 1, because for us to get 2, we have to have 2 divided by 1. Now, we can use Pythagoras to find this side. By Pythagoras' theorem, this is the hypotenuse. 1 square plus 2 square would give us x squared. So we have 1 plus 4 gives us x squared, which means that x is 5. Square root of 5. Beg your pardon. So having found that, we can then write down the sine and the cosine. So the sine of that angle is going to be equal to opposite over hypotenuse, which is 2 over square root of 5. This side is equal to the square root of 5. And the cosine of the angle is equal to the adjacent side divided by the hypotenuse, which is root 5. Here we have another situation where we have the cosine of an angle is equal to 0.7. So first we're going to just change this 0.7 to a fraction. This is the same thing as 7 over 10. And so putting that on a triangle, remember cosine is adjacent divided by hypotenuse, which means that the adjacent is here. So this is 7, and this is 10. And so now we need to find this side. Using Pythagoras' theorem again, x squared plus 7 squared, the two shorter sides squared, is equal to the longest side square. So we have x squared plus 49 is equal to 100. X squared is therefore equal to 100 minus 49. And x squared therefore is equal to 51. We're not going to find the root of it. We're going to leave it as is. So x is equal to the square root of 51. I'm not going to put this in a calculator. Leave it exactly like that with the root sign in there. So this sign is equal to this side is equal to the square root of 51. And now that you have that, we can write down what are the other two apart from cos. The other two are sine. So the sine of the angle will be equal to opposite over hypotenuse, which is root 51 over 10, and the tangent of the angle is equal to the opposite, which is root 51 over adjacent side, which is 7. These situations come up a lot in multiple choice papers, like I said, and it makes sense to know them. It makes sense to become familiar with them.